Welcome back, both to you and our friends the cicadas outside the window, who are clearly very excited to learn. What's that? You want to learn about the hydraulic analogy. All right, great. The hydraulic analogy is a way for us to conceptualize electricity a little bit more effectively than we might otherwise be able to. Because electricity is this weird, tiny, invisible, strange thing. We can't touch electricity. We can't really feel, I guess if you get electrocuted, you can feel electricity, but you can't feel it flowing exactly. It's kind of an odd thing. So there's an analogy, a comparison we can make, which is not complete and total and true, but it's pretty good. And it might help if you're just trying to get a deeper conceptual understanding of the way electricity flows, is just to think about it as if it were a fluid. So, for instance, I'm going to draw a tank. You know what? I'm going to start with a pipe. Here's a pipe. Now imagine that pipe has water in it. Water, and don't worry about the fact that it doesn't have sides on it. Just set that aside for the moment. A pipe filled with water. Will the water flow? No. The water just will sit in the pipe. It might spill out of the edges in this case, but that's like a weird, bad way of thinking about it. It's not relevant to our analogy. And analogies have failures. Analogies have shortcomings. That's one of them. So if we want the water to flow through the pipe, I can draw a connection to it. I can connect it to a tank. That tank has a bunch of water in it, and the water is being pushed by gravity like so. Now, if the tank has a little hole in the bottom, or a pipe attached to it, then it will push through the pipe. What if at the end of the pipe there is a cap like that? Something that will stop the water from flowing. It will push, there will be pressure along that entire pipe, but it won't actually move. So the pressure will flow, the water will sort of press and get a little tiny bit compressed, and there will be pressure along that entire pipe. In fact, the same amount of pressure along the entire pipe. Once it's done, it's pushing and it settles into a steady state, but then it will not go anywhere. What would allow it to go somewhere is if we give it a place to go that's not going to push on it. So we could think of that as like a drain. Like this is my poor drawing of a sewer grate. If we give it a place to go, a drain, then it will rush down into the drain. There will be a flow from here, through here, down into the drain. Well, it turns out this is very similar to an electrical circuit we've already seen. There's a 5-volt power supply. There's a pipe here, and there's a drain over there. And in fact, the word drain is actually even used in electronics to describe a place where the electricity is flowing. So this is kind of like the ground, this is kind of like the wire, and the pressure, the push, is caused by this thing here. The power supply's job is actually to push electricity, and the ground's job is to accept electricity. Just as the water company's job is to push water into your house, and the drain's job is to allow water to flow out of your house. Now, similarly to an electrical circuit, we could imagine building other circuits with hydraulics. So just as an example, we could build a kind of what I'll call an AND circuit. So there's a valve, and here's another valve. It's kind of a weird looking valve. And after that second valve, I'm going to sort of insert an odd thing into the pipe to make this, again, a little bit more like an electrical circumstance. I'm going to have a sort of propeller that's inside a pipe. It's like a turbine. And then at the end of the pipe, I'll provide the drain, the place for the extra water to go, and then it can flow freely into it. It's not going to resist its entering the drain. So what is this like? And imagine I didn't put any water in. Now there's some water. Well, what it's like is this. 5 volts, a switch, some sort of thing that is gonna have the power flow through it and provide some resistance, but also like the power must flow through that thing, and then a ground at the end. So you can actually imagine hydraulic circuits that are akin to electrical circuits. And if you're getting tripped up, maybe you can think about that. Let's take it a bit further. What makes the water move? Pressure. Pressure causes flow. This is an important idea. And let's imagine pressure causes flow. I hope you agree with that. If not, well, let's go back up to here. If we go up to the top example, what causes the flow? It's the push of the water that makes the water flow through the pipe. Without that, the water just sits stationary in the pipe. If we were to cut the tank off from the pipe and just have a pipe there with a cap on it, it will not flow. So it's the pressure that causes the flow. Now, I want us to revisit this thing. What if there's a narrowing in the pipe? So what if the pipe goes from wide to a little narrow bit, and there's a little bit of water that can get through there, but not as much as through the rest of the pipe? Well, if you imagine blowing through, let's say you're blowing out of your mouth with your wide open mouth. Now try blowing out of a very small opening made by your lips. You will notice that you can push the same in both cases, but when there's a small little hole for the air to get through, it's harder to get through there. This thing here, this is a thing that is causing or providing some resistance. And we talked about a resistor before. A resistor, in terms of the hydraulic analogy, is a narrowing in the pipe. It causes a resistance. It resists the flow. And actually, in our circuit, a resistance would be drawn with an explicit resistor, that little zigzag thing. So resistance fights flow. Pressure causes flow, and resistance fights flow. Once you understand those two ideas, you kind of actually have all the pieces you need to know the basics of how an electrical circuit is actually going to work. Now, of course, there's a whole lot more going on. In the next video, we're going to talk about a little bit of the mathematics, but if you can just revert to the idea, pressure causes flow and resistance fights flow. Just keep that in your mind. Think about the hydraulic analogy if you're getting a little tripped up. And we're going to explore how the mathematics behind this, which is actually pretty straightforward, and it follows straight from this understanding.